Hi there guys, I'm Chris Bowden and welcome to the Geek Group. Today we're doing an equipment autopsy of a Breadman plus Breadmaker because I got bored and, well, dangerous things happen when I get bored. So we went out to the local thrift store and I bought a ton of stuff. And because you can get this for like $3 at a thrift store, which is really cool because, well, all the girls of Geek House freaked out when I wanted to take apart a Breadmaker, and well, there's only one in the house, and apparently they're kind of pricey, and that's a thing. I don't know, but it's full of all kinds of neat stuff. So let's take one apart. Now it's got a chamber here, which is pretty much an incubator, and it's got a little non-stick. There you go. It's a little non-stick thing, and there's a keyed shaft on the inside. On the bottom, we've got a standard like a blender type hookup. And this is for when you're making bread. There's a little gnarly thing. It's like a beater that goes in there, and there's a motor that spins it around on the bottom, and it mixes the bread, and it does, all that jazz. So we don't need that. Now, other fun things inside. Let's get into this here. Now we've got, this is an electric heating element. It's a resistive heating element, and these are really good. You want to save these when you're taking stuff apart, because you can use these for resistive ballast. So we're going to want to remember that. And then there's just a basic chamber, a control panel. Let's see what we've got on the back. Nothing, really. And on the bottom, just standard panels. So we're going to dig into this and see what we can find. Now, hey, we'll ask the stream and let them decide. Okay, guys, do we go from the top down or the bottom up? What do you want? We're waiting on the stream. They're 5 seconds behind us, so we got to see. Okay, the stream is absolutely no help at all. They're talking about bandwidth. You guys need to pay attention here. Doing serious business. I'm going to go top down just because it's easier to stand on its base. So we'll take these out. Top down, side on, do a barrel roll. Thanks, guys. You're a lot of help. I'm going top down because that was the first one I saw. I'm not going to put on gloves. I don't think I need gloves for this. Now watch, I'll shred my hands on the sheet metal. I'll be dead in 10 minutes. There's screws down on the inside. I'm just going to take out all the visible screws because this doesn't have to go back together. And as always, we save the screws because those could be useful for another project or for a Geek Group member. And it's fun. What else we got? All right, there's little mounts for these, and I think if I can't really, oh, hey, I can do that, and I can see it from there. There. See, I try not to block the overhead camera with my head, so I can do a lot looking over here in my blocking monitor. They're very serious about having that well mounted in there. Okay. And the little white things here aren't plastic, they're actually ceramic, which is pretty common because, remember, this is holding a heating element, so. Okay, yeah, that's a little ceramic block. Here, we'll give you a look at that. It's kind of cool. All right, now, we're all set there. That feels like it wants to pop out, but it's not. So it's time for the all-new Gerber Ninja, which is brand new, and it doesn't snap yet because it's still wearing in, but you'll notice I have a new Gerber now. It is black. It is the Gerber Diesel in black anodized finish. Now look at this. It's really big, but you see my Gerber, that's our normal zoom size. So I am going to completely hose the video, climb up here, and adjust this the way it should be. Here, we'll use my shoe for an adjustment. Okay, here. Here's my shoe. Now, we'll zoom this in the way we want. There. See how the camera jumps? Like when I zoom in, it's really fast zooming out there, and that stops, it gets really slow. That's where we're into digital zoom. We want optical zoom like crazy. We like optical zoom. Digital zoom, see, optical zoom is like zooming in with a lens. That's the optical zoom. Digital zoom is when the camera just starts taking the edges of the picture and throwing those pixels away, and then it magnifies that. So optical zoom is bad. You're getting less and less image. But look at that. Now we can actually see down in there. And now we can see the new Gerber. Look at that. It's pretty badass. I like it. All right. Let's see if we can pop this out. It appears that it just clips in there. You can see these little mounts. Here, I'll show you. See these little dents right there? Those are little clips. And it looks like these just pop in there, but they don't. It's really weird. It's like it's folded over or something. Come apart. It's very seriously mounted. Oh, hey, we're making progress now. Yeah! Okay, we don't need that. Now we can actually see down in here. You can see the space around it. There really isn't a whole lot to see. It's just a big container. There's not a lot to a Breadmaker, apparently. Here, we'll take this off. There's only one screw on the side of the panel here. There's one back here. Okay. That pops that off. Now there's our whole control panel. Now, if we look inside there, let's rip the wires out. Okay, now let's take a look at the control panel. This is what we have. We've got two big connections out, and these are AC1 and AC2, so these will be our mains power. And they're on there really good. Is that soldered? They look like push connections. There we go. Ah! It's not soldered, it's just really on there. There we go. Okay, so that's AC1 and AC2. And then we've got, let's flip this over so we can read it. Oh, cool, they even labeled them. There's the heater, so those are the heating coils. And on these types, you can see there's a little thing inside, so you push that up, and these pop right off. So those are our heater. And then the next one is the motor. And then down on the bottom is the fuse. So we'll take that one off, just like that. And then over here, what's that one? Thermistor. Now a thermistor is therm, which is heat, okay? And it's an istor, which is, I don't know, resistor, I think is what they're going for. But it's a variable resistor based on heat. So it's like a potentiometer is a variable resistor that changes by positional data. A thermistor, as it gets hotter, the resistance goes down or something like that. I don't know, but we'll find out. We'll dig into it. Some other stuff to find on the board. We have this little thing. Now, there's no, we can't really see anything except its label. So let's read the label and figure out what it is. Omron. Now, Omron is a company that makes a lot of relays and timers and stuff like that. Now, over here it says contact and 10 amps at 250 volts DC, 3 amps, 30 volts DC, coil 12 volts DC, and then over here 12 volts DC made in China. So this is a 12 volt DC relay, and it's got, a 12 volt coil that will handle up to 240 amps or 240 volts at 10 amps, no problem. So it's a rather beefy little relay. Over here, we've got an iron core, a laminated core, and then a winding here, and a winding here, and a big winding and a little winding. So this is a transformer. This converts voltage from low to high or high to low. What else do we have? We've got some little can with a stripe down one side, and the stripe is labeled for polarity. So that is an electrolytic capacitor. These down here are diodes, and there's 4 of them all together, so that is a rectifier, most likely. Wherever you see 4 diodes and are all bundled together, it's almost always a full wave bridge rectifier. Down here, these little discs, those are capacitors, and you can save these. You can desolder them off the board and use them for stuff. We've got this little thing, which is a little black can with a flat side and 3 wires out the bottom, so that's a transistor. Another diode. These over here are resistors. Looks like an ant, kind of, with a wire coming out of each end. That's a resistor. And lots of plugs. Resistors up here. You can see resistors are labeled like R something, R4, R7, R8. Let's see what else we have. What is that? That looks... I have absolutely no idea what it is. I think it's a fuse. I think it's a fuse, or see this, depending on what it is. No, it's a capacitor. Okay. See this, depending on what it is, could be a fuse, it could be a capacitor, it could be a relay of some kind. I could not figure out easily what it was, but if you look at the board, C1, and then there's the brackets for it. So that is a capacitor, C1. Because if we look next to this capacitor, C2, C3 for the little disc capacitor down here. So we know they're labeling capacitors all by C, just like they label resistors by R, so that's a capacitor. Cool. And then we've got the cable that takes the power off. Now what is that? See a little yellow box, 2 wires? Well, we look next to it, it says C8, so that's a capacitor. And kind of a nifty looking one at that. It is a T1N0K63. So comment and you can say what that is. Let's look at the bottom of the board and see what we can find. Because you can see all the stuff on this side of the board. Now, circuit boards usually have 2 sides. They have the solder side and the component side. Well, this is the side that has all the components on it, so this is the component side of the board. Oh, also a thing to talk about. Well, let me get this other board out and I'll show you. There's actually 2 boards in here. And a lot of screws. Now, a bread maker has to be, as appliances go, pretty smart, because, we'll come back to this, because the bread maker has to know when to do stuff. It has to know when to heat, it has to know when to have the motor run, it has to know stuff. It's computery. So we've got the board we were looking at right here, and it's got that cable that goes off. Well, that cable goes off to another board. Look at that. So we've got a whole bunch of LEDs here. LEDs are little lights that they're not incandescent. They're not like a regular light bulb with a tungsten filament. LEDs are light-emitting diodes, and it's a semiconductor. And LEDs are cool because they stay very cool, and they work for a long time, and they're pretty much impervious to vibration. Whereas if you take like a mag light, a little flashlight with a regular halogen bulb in it, and you whack it really hard against your hand, the bulb will burn out because the little tungsten filament will get knocked loose. With an LED, that's not a problem. So they use, and LEDs tend to be a lot cheaper nowadays too. So you can buy these by the thousands. Now these little things here are buttons, the little micro switches, and if you listen, you can hear them. See, that's a micro switch. They make a little clicking sound. We've got a lot more resistors and little small semiconductor bits. Okay, like there's a resistor. Here, it's a little black thing with a flat side. Now this one isn't round, it's smaller than the other one, but that is another transistor. And this thing here is a liquid crystal display. And oh wow, it's sensitive to touch. If I push on it, you can see some of the display properties in there. So that's kind of cool. Liquid crystal displays are always sensitive to touch, but this one's particularly sensitive. Now, over on the other board, this thing over here, because somebody on the live stream asked about it, this is a speaker. It's a piezo element speaker, which is a kind of solid state speaker. Instead of a magnet and coil, it actually uses a crystal and a couple pieces of metal. on the bottom, now here's our component side, here's our solder side. You can see the traces. This lighter shade of green is actually copper. The whole board is coated, the board itself is made out of a phenolic resin, just think fiberglass and plastic and epoxy, okay? And then they glue a thin sheet of copper, just metallic copper right to it, like a thin, like copper, like tinfoil. And then they can make masks. It's a photographic process. And you put a chemical on it, and wherever there's lines on your thing, it can eat stuff away so that you end up with this. And these little lines that go between things are actually wires. So if you flip the board over, you can look at this side, and you can look at this side, and you can know, like if you look here and you see, I don't know, the speaker, okay? We flip that over, and we can see the speakers right there, and there's two silver blobs. Those are solder. And then you can see the wire that carries the electricity off to the next thing. So we know this speaker is connected to this thing here with three little blobs, and I put my finger on it, and we'll flip it right over. And it's right here, these three components, which are all resistors. And we flip it back over. Now we know this side of the speaker is connected to this really big one. Now this big one connects to a whole lot of stuff. So this is ground. Almost always, of course there's exceptions, but almost always if you're looking at a circuit board and you see a big main trace that everything connects to, it's almost always ground. Now over on this one, we've got our display, and then on the back, we can see that all these wires, because the display is all these wires here. So we can flip it right over and we can see the display goes to here. And this drives all these wires, and they go out to the display. So this is the display driver. And I'm also pretty sure, because of all the other things this connects to, which is all the buttons and stuff, this is the little microprocessor that controls the Breadmaker. So this is what makes the Breadmaker smart. This is its brain. And all the rest of the stuff is just to turn motors on off. This is like power supply stuff. It interfaces the motors and the thermistors and the fuse that's our power in and all this stuff. This is the I/O. Okay, this lets it interact with the real world, but this is the heart of the Breadmaker right here. That's the brains of everything. So now we've got that sorted out, let's look at this and see what we can learn. I'm going to take this top piece off. And it's all just really cheap sheet metal. I mean, this thing's really cheaply made. It's not an impressive Breadmaker by any means. If I built a Breadmaker, I'd build it at an 1/8-inch thick aluminum plate. Manly Breadmaker. Of course, it'd weigh 200 pounds, but really, how often do you got to carry your Breadmaker around? You know, it's not something you move a lot. Don't need that. Okay, now we've got, look at this right here. Oh, hey, look, it's held together with a twist tie. I swear to God, look, hang on, I'll show you. There's a twist tie right here. And not even like a good, gnarly one. It's like a crappy garbage bag twist tie. Now this thing right here, that's our thermistor. Now it's in a little silicone sleeve, and I'll see if I can, nope, but I can rip it apart. That's useful. Okay, this is our thermistor. And I'm going to save this because Paul, who is our electronics guru, is going to be back here soon. And when Paul comes back, we'll talk about the thermistor in an upcoming video, and Paul will like that. Paul, are you watching a live stream right now? I have no idea. I don't know. Okay. Huh? Is he in there? All right, now. He's in the IRC? Yeah. All right. But I don't know if he's active. Okay. I'm going to cut this off. Now, this particular wire has a really thick cloth coating. So that tells us it's a high temperature wire. And I'm going to see if I can wiggle this out. There we go. I had to cut the end off so I can get through the two holes. But here is our heating element and its little ceramic mount. So this would be an excellent thing if you're building a Tesla coil at home and you need something like, let's say you're using a Mott or two, and you need a resistive ballast for current limiting. Right there, excellent current limiter. They're great. They'll take pretty good abuse. It's just a big resistive heating element. Because this thing, to run, uses a lot of current. Well, because it uses a lot of current, you can use this as a current limiter for your transformer. You just wire this in series with your Mott. Now, the downside is it's really lossy because this is going to get rid of a lot of energy in the form of heat, but it will pass the current. You can use it with your transformers. So we'll talk about that in an upcoming video when we do a thing on Mott Tesla coils. Now I'm going to dig down in the bottom here. I got 3 bolts on the bottom. I'll pop these out. There are, at this point, a great many sharp edges all over this machine. I'll pop that off. Okay. Boom! There goes our container. There's wires on the side of that. What are you? I got another pair of wires down. I think that might be another thermistor or something. Nope, this is a fuse. Remember how the other wires went off to the fuse? Okay, check it out. Here, I'll show you guys. Boom. Slide off the protective covering. I gotta bring it down there so it'll focus. But that is a fuse. So that's your main power fuse to the thing, which looks rather beefy. It might be like 10 amps or something. I don't know. Well, it's got to run the motor and the heater and all that, so there's a fair bit of power involved here. Now, here's our actuator. That's not a happy sound. Oh, it's moving. I think we got to go in the bottom at this point. We got one more thing here. Let's take this out real quick. I don't know what it is, but it looks like a circuit breaker. This is, no, it's cap. This is 250 volt, 10 microfarad capacitor. Ta-da, okay, don't need that. Now, let's flip it over and dig inside. Now we're going in the bottom. Down in the bottom, I think the only thing we're going to find is the motor, but we'll find it. In case anybody's curious and you want to compare this to your mom's, this is a Breadman model TR800 Breadmaker, 530 watts, which is actually pretty good. That's just about perfect to ballast a Mott with. So yeah, if you need resistive ballast, if you're playing with microwave oven transformers for your Tesla coil, get an old Breadmaker. And the more watts on the bottom, the better. Now we know what LERFs are. Does that count as a BERF? Those that don't know, LERFs were covered in a previous video, several previous videos. LERFs are little rubber feet. You find them on the bottom of a lot of stuff. Now these are rather beefy rubber feet. These are big rubber feet, so we'll call these BERFs. Oh, you're off, okay. They're tenaciously mounted. I think the motor came out. Okay, and we've got our feet. Oh wow, look at all that motor. That's way more motor than it. And there's a belt drive. Man, we got all kinds of stuff here. Look at this. This just got way more interesting. Okay, take a look. I'll show you what I got. We got a big motor. Big motor. We got a pulley thing. So here, let's tear into this. This is a big 30-watt motor, 120 volts, 30 watts. And it's probably going to be a pretty good motor because, I mean, it's got to run a Breadmaker. So I would not at all be surprised if the motor is reversible. Pull that off. Yeah, now here's our big, it's a toothed pulley. There, you guys can see that. Here's our big setup. Don't need that. Don't need that. Let's get rid of all the crap. All right. Wow, it's a good sized motor. You guys want to take the motor apart? Let's do what we can. We'll get into it. I don't know how apart I can get it without getting out like an angle grinder. And I think if we tear into the motor at that level where we're like taking apart the windings and the laminations, that should probably be a video unto itself. Now here's our motor. Look at that. That's a prize. Now it's got two sets of wires that come out, red and blue. Oh, remember that big capacitor we took off earlier? That is the motor's start capacitor. Absolutely is. Now let's find that. I tossed it over. Okay, now look. We've got this capacitor here. A chair back. Now we can take this capacitor and hook that up on here, just on a couple crimp connects. Okay. And then we put power in here and the motor will spin up. So we're going to play with this later. We'll come back to this. I got to get some crimp connectors and stuff because I ripped those off when I took this out of the case. But we're going to play with this. This will be a thing. So we're going to save this motor. We're going to save the heating element. We're going to save the thermistor. And we're going to can the rest. But we're going to come back to those in future videos and play with that. We're going to play with the thermistor with Mr. Kidwell because he's the electronics guy. We're going to play with the motor with, I'm going to do that myself just because I'm cool like that. I just got to crimp those things on and we'll come back and do that. And then we're going to use this with Tesla coils because Billy has been eagerly awaiting the moment when he is approved to play with MOTS in the lab. And he's not quite there yet. I want to have him get his first coil under his belt and get electrocuted a couple times and learn the safety of things. And then we'll get him into the dangerous stuff like MOTS. But that's coming, Billy. I'm going to set that aside for you. So there's your look into a Breadmaker. Thank you guys for watching. Please remember to rate, comment, and subscribe. And please donate. Go to thegeekgroup.org and make a donation. I don't care if it's $1 or $5 or $100. But it's your donations that make this stuff possible and allow us to keep making these awesome videos. So you guys have a ton of fun. I'm Chris Bowden. I'll see you next time. Thanks.
This video was made possible by a grant from the Future Girl Foundation.
This video was made possible by thousands of private donations from members and viewers like you. Please visit thegeekgroup.org for more information on how you can donate and become a part of our dreams of Avalon.